Hi, this is Algebra 2, Lesson 84. We're going to talk about degrees of equations and solutions to systems of equations. We're starting on page 346. Okay, here's some review of degrees of equations. To start with, the degree of a term of a polynomial is the sum of the exponents of the variables of the term. So the degree of 2 is 0 because there are no variables in this term. The degree of x to the third, x to the 3, is 3. It's a third degree term. The degree of x squared ymp would be the degree of this is 2, the degree of this is 1, and 1 and 1, so this is a fifth degree term. The degree of 47x is a first degree because the x is to the first degree. So the degree of polynomials, either expressions or equations, is equal to the degree of the highest term in the polynomial. So 3x squared has a degree of 2 because x squared is the second degree. 2x is a first degree, and 5 is a 0 degree because there is no variable. So the term with the highest degree is 3x squared, so this is a second degree polynomial. Okay, now we have 3x cubed plus 2x squared plus 3 equals 0. This is a third degree term, this is a second degree term, this is a 0 degree term because there's no variable, and this is a 0 degree term. So the term with the highest degree is this one, and it's a third degree term, so this is a third degree polynomial equation. xy plus 5, this is x to the first and y to the first, so the sum of these exponents is 2, so this is a second degree polynomial. This is y equals 3x plus 2, this is first degree, and this is first degree, this is 0 degrees. So this is a first degree polynomial equation. First degree equations with 2 or more unknowns are called linear equations, and their graph is a straight line. Okay, here's a little bit more review. Solutions to systems of equations. When we have a system with 2 linear equations, there are 3 possibilities for the number of solutions to the equation. The first possibility is that they have one common solution where the lines of the graph cross. Okay, so we have 2 equations. We have y equals x plus 2, and we have y equals negative 2x plus 1. Alright, so if we look at these 2 equations, if we graphed them, they would come out like this. We see the slope of y equals x plus 2 is 1. The slope of y equals negative 2x plus 1 is negative 2. The y-intercept of this equation is 2. Right there. And the y-intercept of this equation is 1. Okay? So here's the graph of y equals x plus 2. Here's the graph of y equals negative 2 plus 1. And the place where the equations cross is right here. So each line has an infinite number of coordinates, but there's only one coordinate that satisfies both equations. The second possibility is that the two equations have exactly the same graph. So here we have the graph of y equals x minus 2. If we multiply all of these terms by 2, we get 2y minus 2y equals 2x minus 4. The graph of these equations are exactly the same. Both lines share an infinite number of coordinates because the equation is actually the same equation, just in a different form. The third possibility is that the lines have zero common solutions. This happens when the lines are parallel. They have the same slope but different intercepts. So we have y equals 2x plus 2 and y equals 2x minus 2. We can see that the slopes of both of these equations are exactly the same, but the y-intercepts are different. This one has a y-intercept of 2, and this one has a y-intercept of negative 2. But the slopes are exactly the same, so they are never going to meet. So there are zero common solutions because they're parallel lines. So, to summarize, in our first option, the lines cross at one common point. In number 2, the lines overlap because their equations describe the same line and they have an infinite number of common points. And in number 3, the lines are parallel and have no common points. If a system has one solution, we can find it either by graphing or by using the substitution or elimination method. And we've done that before. If we did substitution or elimination, we would find y equals a number and x equals a number. And that would describe this point. If a system has an infinite number of common points, solving by substitution or elimination will result in a true statement with no variables, such as 5 equals 5 or 0 equals 0. If we solved for these equations using substitution or elimination, we'd end up with 0 equals 0, which is a true statement with no variables. So let's do that. So let's use elimination. We're going to multiply both sides by negative 2 on the top. So we'll end up with negative 2y equals negative 2x plus 4. We're going to add that to the bottom equation. And that's 0, 0, and 0. So we get 0 equals 0, which is a true statement. Okay? A system of two equations whose graphs are parallel has no solution. The variables will be eliminated if we solve it by elimination or substitution. The variables will be eliminated and the result will be a false statement, such as 0 equals 5 or negative 3 equals 7. So let's try it with these two. These are the two equations we graphed here. And let's use elimination, and we're going to multiply the bottom by negative 1. So we have y equals 2x plus 2 and minus y equals negative 2x plus 2. So this cancels and we get 0 equals 4, which is false. And that's what is always going to happen when you use substitution or elimination with two equations which would graph into parallel lines. Okay, a system of equations with at least one solution common to all equations in the system is called a consistent system. So this is a consistent system because there is at least one graph, one point in the graph that is common. So this is a consistent system. This is also a consistent system. It actually has an infinite number of points that are common to both equations. This one has 0 points that that are common to both equations, so we would call this an inconsistent system. Okay? A system of equations is a dependent system when one of the equations in the system contains all solutions common to the other solutions. In other words, if they share an infinite number of solutions, so in this case, it's called a dependent system. So this is a consistent system and a dependent system. Okay? If this is dependent, then this is obviously independent. And so is this. Okay? So this is an independent system and a consistent system. This is a consistent system and a dependent system. And this is independent system and an inconsistent system. This system has one solution in common. This system has an infinite number of solutions in common. This system has 0 solutions in common. And that is it for this lesson. If you have any trouble graphing equations like these, I recommend you go back to my Algebra 1 lesson 81. It goes through exactly the same information, just we do a lot more graphing. So if you still have any trouble graphing these kinds of equations, go back and watch Algebra 1 lesson 81. Otherwise, just try your practice problems and let me know if you have any questions and do your homework. Thank you.